All right. Well, thank you very much, Vanessa and Nikki, and also to our sponsors. So hello, everybody. I'm Judith Lacoste. Today, I'm in Liverpool, UK, but I'm nonetheless going to proceed with my usual land acknowledgement. So I respectfully recognize and acknowledge the relationship that the First Nation, Inuit, and Métis people across Canada have with the land that all Canadians live on and enjoy. I recognize human rights of people who have suffered from systemic racism and discrimination in Canada. I seek to provide a welcoming, engaging, and safe community for everyone. So again, thank you everybody for being here. Katrina is unable to attend. She's sending her apologies. So I will I'll be your host and provide a quick introduction to our speaker today, Alex Rigano, who's a part of Katrina Strambio de Castilla's lab. And I'm a close collaborator with Alex. And the story behind this is as follows. When you want to upload data into an Omero instance, the fastest route is usually to use a software called Omero Insight. And this allows you to effectively upload data sets into your Omero instance. But if you have a lot of data set and you also want to annotate them, for example, as per the recommended metadata for bioimaging data sets, you also want to automate this process. So Alex in the past has written a software that allows you to upload and annotate your data set, for example, overnight, so that you don't have to sit and click individual files and annotate stuff in a long and tedious process. Early in our collaboration with Canada Bioimaging, we came to realize that the software that Alex had written was needed to be adopted from one site to another. Just in the city of Montreal, we needed to update according to the various contexts of different labs, uploading data sets in our one common Omero instance that we have in Canada. So instead of rewriting everything for each particular institution, Alex went around and surveyed the community and asked, if I'm about to rewrite this, what would be the best practice to do so? And the international community came together, gave advice and suggestions to Alex. And Alex has spent a great deal of time in the last several months rewriting this Omero importer that allows you to not only upload but annotate your data set. So today he's going to present his work towards that new version of the Omero importer. So Alex, all to you now.
Unmute. Okay. Hi everyone. I hope you can see the screen now. And okay, perfect. I'm Alex Rigano. I work as a software developer in the Strambio lab, and my current focus is software for metadata collection and organization. Some of you may know about Micrometa app, maybe. It's one of the software developed that helps for metadata regarding microscope and image acquisition. Today I'm talking about this new software, more a solution than a software, because it's not just one piece of software, but is several pieces of software plus a spreadsheet, and that is trying to solve the issue of what do you do with data, because it's a big issue. So the data comes from microscope view. There is a whole set of data that comes before the publication, and this data needs to be annotated and needs to be organized properly, because otherwise when you end up arriving at the publication level, you don't know which image comes from where, how, and all the other questions related to the image. So it's like data management for pre-publication instead of data management for publication kind of thing. And so our purpose is to make it fair from the start, from the beginning. So whenever you load data into a repository, you try to already put everything there that you may need in the future. And this part is obviously like challenging, difficult, like Katerina likes to say, challenging, difficult, scary, and almost impossible. And so I'm going to give a little bit of an introduction of who and why, and then what, and then a big part on how. So the who is we at UMass and a lot of other people at Canada Bioimaging, including Judith, that graciously introduced me, are trying to create a collaboration, including Claire Brown and Thomas Stroh, to improve the practices of open science and facilitating the metadata annotation, and then to upload these images and the metadata into Omero instances. So one part of our project is us, obviously, me and Katerina and all the other people at UMass, and the other part of the project is Judith, Claire Brown, and Thomas Stroh. At the Canada Bioimaging, they are using, correct me if I'm wrong, Judith, but an instance of Omero that was installed by Stephen Ogg, that I think is here today. So thank you, Stephen. And they are trying to promote pre-pub data management to facilitate post-pub sharing. So same aim that we have. We at UMass are using an instance of a local instance of Omero that has been installed originally by Vanni Galli, and that me and Carl reinstalled a couple of years ago. It's local to our lab at the moment, but we are in the process of trying to expand it to UMass world level. And we have some collaboration already with other cores in the university. So what is our vision here is we are trying to create a Omero core at UMass to make a state-of-the-art bioimage data management and analysis at all scales. So like increase the effectiveness, the awareness and the expertise of people that are using Omero, and that they want to be using Omero, and then they want to annotate the data, and they want to keep all the data together, and trying to make everything fair and try to automatize as much as possible to try to remove the burden from scientists that have to do all this job that is challenging. So some of you may know this image because it's been like a staple in a lot of presentation, and is like the bioimage town, like how to connect everything together kind of thing, like going from the microscope to the image data storage to the platform and then to the public archive, how to keep the data flow together, how to keep the annotation together, how to keep all the information that are necessary to achieve the end goal of having a proper publication with all the data and the metadata together. Obviously, this is not something that you get out of the box, like by installing one piece of software on one server and everything works fantastically. So the first issue is gather raw data, and where you put those raw data and where you put the metadata associated with it. And it's already like a difficult and inefficient task, because a lot of time there are several different files that comes together to like create the package that you actually need to carry through the whole pipeline. And now there is going to be going forward a mandate that you need to have the data shared and the metadata associated with it, so that the experiment can be reproduced. So you need to actually have something that connects all of this together and try to like make it easier for scientists to have all the information that are necessary. So for this purpose, we already developed MacroMetap tool. I'm going to show a little bit of it later, just mention it later again. But in this solution that we are proposing today is like trying to save the experimental metadata in a as much as possible automated manner into Omero straight from the acquisition computer, where you take the images, or an analysis computer that you're using for as a transition point between your microscope and your data image repository. So as Katerina mentioned, spreadsheet city, so where you annotate all your data, when you collect all the annotation, when you try to put everything together that regarding your experiment, there is going to be this solution that it's called Omero Importer, and maybe it's a little bit like how you say big aim to call it Omero Importer, but it's like we are trying. And it connects itself to the other part that we already developed, that is MicroMeta app. So it's basically able to read the data that is being produced by MicroMeta app and use it for additional annotation when the image gets transferred and imported into Omero. Most of you already know what is Omero, but in case you don't, Omero is a image repository that is been taking over like the biologist bioimage data management in the last 10 years, I would say, and is able to store raw data, process this data, and visualize all the data, store experimental metadata in several different ways, such as tables and key value pair, and perform queries and store results of quantitative analysis in case you have them. Why Omero? Because Omero is currently the most used bioimage repository, as shown by this very nice graph that I acquired. Why user like Omero? Because it's great to make figures for publication. This is some of the feedback that we actually received from users that tell us, like, after we convince them to use it, why they like it and why they stuck with it. It makes it easy to organize image data and using tags, comments, and ratings. It makes it easy to show results to boss colleagues, lab mates, and it's easy to share data after. So at the end, when you have done everything and you want to publish it, it's easy to actually publish it and make it available. So why do we need this additional tool? Because as Judith mentioned, is like the alternative is spending a lot of time with Omero Insights, or having most of the other solutions that I'm aware of are a higher level of complexity, I would say, and requires a lot of infrastructure that a lot of smaller sites don't have. So they cannot afford to have like a whole shared file system or other stuff that other bigger solution have. Obviously, one other very common comment is I don't want to spend an eternity annotating everything, that a lot of this data I may not even use it at the end. So how am I going to solve that? I want to search images for relevant information to my experiment. If not all images are annotated, you are not going to be able to easily find images that are like maybe interesting for some side purposes. And I want to deposit all those images together with the relevant metadata. So this is a common problem, because at the end, if you have metadata saved on files that are not directly linked to the image, you have to save those files somewhere that can be easily found too. So what does Omero Importer Metadata Annotator actually do? The biggest part, obviously, is upload images from a designated local target folder to Omero, automatically transfer metadata from spreadsheet to key value pairs annotation, automatically add tags based on folder structure, and automatically upload MicroMeta app JSON files as IMAs attachment. So this is a little bit of an overview of how that works. Like, we have a spreadsheet with all the sample preparation metadata. We may or may not have an additional image acquisition metadata coming from Micrometa app. We have a data structure on the file system. We run our Omero importer new version Pi, and we upload it into Omero. Into Omero, this is a test project that we ran previously. So you can see the project level, the dataset level. This is a notation that has been written on the dataset level, the higher part here, the key value pairs. And this is an example of how the attachment of the JSON files for the microscopy metadata, so the microscope, and the image settings are going through inside Omero. So as I was saying, this is more a solution than a single tool, because this is three different parts, three different components. One component is the Excel spreadsheet with macros. The second component, animation, okay. The second component is Python Excel helper script. So it's a script that basically runs inside the Excel spreadsheet. And the third component is the biggest part of it, that is the Python importer. So a simple example of the workflow is you launch the metadata annotation spreadsheet, you fill in relevant project and metadata and the dataset level metadata. You acquire the images and place it in the proper folder structure. Then you run the Python helper Python script. You fill in the remaining relevant image level metadata, and you run the Omero importer. The Omero importer can be run standalone, but the idea we develop it for is to run as a nightly job, so then not to overload the servers for, as again, like smaller setups like we have. And once that's here, a little bit of more of a generic structure of how that works. So this is an example of the folder structure that we have that you may encounter in your acquisitions. So we have a user, a project inside the user, data set inside the project, and then we may have additional tag or mutation or wild types or whatever it is that your experiment has that you want to differentiate between images. And inside there we have images, and again, we may or may not have Micrometa app files. Inside the Excel spreadsheet, we have metadata annotation, and always inside inside the spreadsheet, we have an image list that contains the name of the images and relevant information about the images that is used for the purpose of the importer. And then we have key value pairs coming into Omero, and the data structure of the same data structure that you put there is imported into Omero. Before I show the spreadsheet in more details, like the spreadsheet uses Ramby-based color coding to make it easy to actually understand what is what and where it's coming from and why it's defined in a certain way. And again, to try to be as fair as possible. The project datasheet this is again one simple example. We have a part that is used for the purpose of importing into Omero. So these metadata are not actual metadata from the image, or better, it's partially actual metadata from the image, but is not used for annotation. It's just used for like finding the project or creating the project into Omero and associating everything with it. And then this part instead is going straight into the key value pair, obviously removing the model. The model is just for a representation for the spreadsheet level. Same thing for the dataset datasheet. We have like a set of metadata that is used for the purpose of the importer, and then we have annotation, subsequent annotation. This is just a little portion, it's not the whole dataset. There is several different section of dataset annotation underneath it. So a little bit more to the meat of it. This is the image list where some of the magic happens. So the images, when you open a template, is empty. What you need to do is actually tell in the Excel which kind of image are you working with. And this can be multiple images. If you have different extension of images, you can add multiple different extension of images. In this specific case, it's just CZI. And then you run the script using this macro button here. This launches a Python script underneath Excel that populates the Excel with all the images that are found in the folder that has the same dataset name as this specific spreadsheet. So you indicate which dataset you're working in the previous page where the dataset image, let me go back here, this specific field dataset name, and this is going to be the folder name that the script is going to explore. Once the exploration is done, in case of tags folder, a new name is generated, as you can see here. A new name is generated for that specific image, and you may leave it if you want to keep it like that, or you may rename it back to whichever name is more convenient for you. The new image name is literally just taken as is and used to generate the image in Omero. There is an image path, MMA file path in case MMA file are present, tags that are coming from the folder structure, and then the user need to go in and fill whichever metadata, additional metadata annotation they want to fill in. And at this point, you run the Omero upload, the Omero importer, and you find all your information going straight into Omero. As I mentioned before, if the project is not present in Omero, the project is getting created. If the datasets are not present, they're getting created. The images are getting transferred, and the metadata annotation is getting transferred. And additionally, the tags that are not present are getting generated in the Omero server and then getting associated with the relevant images. Once this process is finished on a nightly run or in a regular run that you start by yourself, you are going to receive an email including the information about the images that are getting imported, what happened if there are errors. And this is an example of the user email. And then there is an administration email that instead contains logs and extensive information about everything that has been done, whatever was read and whatever was actually written. The Omero importer script has two configuration files. One is a global configuration that basically contains all the information relevant for the script to run. And as you can see, it's encrypted. So the configuration needs to be generated using the script itself so that the encryption actually obfuscates some of the data that are more sensitive. And a user-specific configuration that is optional. So there are some stuff that can be override using this configuration for certain special user or whichever is the case for that is necessary for your setup. Okay. Some of the features that I didn't mention in the presentation, but they are there, is that you can copy the data to a destination folder. So you take the data from your origin folder, and you may want to move the data somewhere else while you're doing the import too. So you may have a backup folder on a separate hard drive or a separate network drive or whatever is your setup. So there is an option to actually do that together. So he uploads the images and then he copies the images out. Additionally, there is an option to delete the images from the origin folder. So if you set this up, the origin folder is always going to delete everything that is already been imported. There is an option to backup the data on a cloud-based storage. In this case, we are working, one of our lab we are working with wants the image backup to Backblaze. So there is a module there for doing this, and it can be easily expanded if someone uses AWS or whatever solution you're using. There is an option for skipping macro metab files in case someone doesn't have macro metab files. There is an option to set up a start and end time in case the software is run as a cron job, as a scheduled execution. There is option for adding an automatic email sender. Obviously, if you don't add it, the email are not gonna get sent and received. And there is an option for adding administration emails for receiving additional information about when the software is run. Our plans for the future is to integrate Omero metadata, that is a library for adding metadata automatically to the dataset level and then getting it linked to the image. That will mean that on addition to key value pairs, we are actually able to write tables too that may be useful for some cases. We're define a little bit and improve the error system and how it's handled and how the email in case of error are sent and what's written in them. It's a little bit iffy with working with exception in Python, for me at least. I'm not a Python expert. Adapt the script to handle screenplay well. That is a problem that Judith has currently, and we are going to have to work on it. It's probably one of our next step of development. And then more down the line in the future, use Omero CLI transfer to be able to download the images and the metadata to everything together as a package, possibly a human readable package and not just something that can be read only by another instance of Omero, to be able to deploy it somewhere else in case it's necessary, or even just to be able to transfer it to a different Omero repository. And with that, I come to the end. And I want to say thanks to everyone that contributed to this project. And specifically, one little additional thanks to Eric Ratamero and the Jackson Lab, because I'm using Easy Omero, and I don't know how I would have done it without you guys. Thank you, everyone. If there are any questions, please feel free.
Right, excellent. Thank you very much, Alex. So are there any questions or comments? We would be very, very interested in hearing what people have to say.
I think Michele has a question.
Yeah, thank you. It was really, really good talk. Really, this is more on the going to the practical side. It's like, how do you, but you managing like the security side since you're using Excel macros? That makes me a bit paranoid. The idea of teaching users about running Office macros from an IT security perspective.
I know, but like the only other alternative is teaching users to run Python scripts, and I don't know which one is easier. So
yeah,
it's like the software can be run as a Python script itself, so it doesn't need to be embedded in an Excel macro. We did that just because of most users don't want to learn how to run a software from command line. Even more when that requires like additional effort, like activating a virtual Python environment or anything else that is more than just clicking one button. Like I understand the concerns. It's like we have issues on that side, like plenty of things like are problematic on the side, but the reality is that at the end is scientist driven. So we need to give the scientists what they need to make the job done, kind of thing, and in the least amount of step possible. So I hope that answer is like, I know it's not really an answer because it's like it's not an answer of how we secure it. It's more of an answer of why we do it this way, and it's kind of insecure.
No, it's totally true that we have these love-hate relationships with the spreadsheet. And yeah, as Alex say, a lot of people hate them, but down the road, most people, that's what they're asking for. So at the moment, that's maybe the least offensive solution. But hey, we can certainly develop future more elaborate solution for the future.
Are there any more questions?
There's another hand up. Please go ahead.
I have a comment and a question. I applaud you having the macro to pre-fill in the image file paths and image names.
Yeah.
Because at Jackson Labs, we do have our own kind of similar automated import system. And half the time we're having to check over the user's submissions because they've left out an extension, they've misspelled an image name, and the importer is failing because of that. And so far we still have to do that because we allow them to give the spreadsheet to the microscopy core that then puts it in the Omero. So there's a few steps between the user making their spreadsheet. So yeah, I have a question of when the data set or project already exists in Omero, what's the process for the importer for that? Does it overwrite any new description?
So there is an option actually inside there that we didn't add in the spreadsheet yet, at least in the example that we show, but is in the new version that we are currently testing, where there is a field where the user can click override metadata or not. And then, and then in the during the importer process, if the option is selected, then obviously it gets transferred from the Excel spreadsheet to the importer. And then if the option is selected in the importer, it basically overrides all the metadata in case someone made an error in all the images or something like that. Because it's one of the common issues that we have. Again, typos. Yeah. Typos are the evil of the world. And yeah, that's it. I think that answers. And thank you again for easy Omer.
That's Eric. I'll tell you, you said that.
But I think that's the whole point, right? We're all struggling, resources are limited, and when we can work together, that's the way to go, honestly. So, and I can also comment that there was a lot of activity at the AIMM meeting in terms of data management, and we're gathering a big crowd. So, all right, let me see. Anybody wants to add anything? All right. So, Alex, I just want to inform you that I am making progress with the annotation for the plates and well. I was just not, yeah. So I figured out that actually when there is an HTD file associated with your data set, what you want to do is actually just in Omero Insight, you actually just select that one and only file, and then it does read into Insight, and then you can run the data set to plate script. So we're making progress this way.
Okay.
So I'm really happy about that. And
we do have to work on that part.
Yeah, we're gonna need to work on that part. And at AIMM, we started kind of a new group of people that are also using spreadsheets. But spreadsheets that incorporate controlled vocabularies and ontologies, so that actually people are not necessarily going to have to type in information, but select from a drop-down menu things that are going straight to on.
We have part of it already in the.
That's right.
Spreadsheet. We have allowable values for certain fields. Yeah.
Yes, exactly. So even though they're spreadsheet, we can at least restrict the typos in that manner. All right.
Hi, John. Please tell me.
Hey, Alexandro. John Ortiz from Smithsonian Tropical Research Institute. We have a project in this data acquisition and just really new in Homero. Thank you for the good process of automating this task. And my question is related to, you mentioned during the presentation several times, Easy Homero. Can you take me a little bit what is Easy Homero, please?
Sorry, can you repeat what Homero?
What is during your presentation, did you mention several times Easy Homero?
Easy Homero.
Easy Homero. Okay,
yeah.
sorry. Easy Homero is a library that is being developed by Jackson Lab. So the problem with Homero is that the only library currently that allows you to import images straight into Homero is written in Java. And if you want to write something that is not Java, it's not that easy to interface with it directly. Jackson Lab came up with this solution that basically wrap the Java library inside a Python package. If I'm correct me if I'm wrong here. You know it better than me. And it allows you to basically use the importer functionality of Java inside Python.
Okay.
And that solves a lot of issue if you want to write some Python scripts, because you don't want to redo all the job of writing function to actually make simple operation in Homero.
Wow, perfect.
Yeah, to clarify, I think Homero does already have a Python API through Blitz.
Yep.
It's just extremely verbose.
Yep.
You have to write 20 lines to do anything. So Easy Homero, besides some HQL calls, mostly writes wrappers on the existing Python Blitz API for Homero. Just makes a lot of things easier.
Okay, thanks.
All right. Excellent.
Thank you.
That's really
Can I just
useful.
get a little clarification there too? Did you say Blitz API? Is it Blitz or Blips?
Blitz with a T.
Okay, great. We're trying to take
TZ.
notes.
Yeah.
Okay. Thank you.
Here, I'll go.
Great, thanks, guys.
Excellent.
Thank you, everyone.
All right. Are there any other comments?
Last minute comments?
Last minute comments? All right. Okay, then. So I have a question for you, Alex. If someone is interested in giving a try to your tools, your toolbox, how should we proceed?
So we currently have 2 GitHub repository that I think I mentioned. Let me pick the slide again. It was towards the beginning. Sorry. Too many animation to go back to. May I do like this? Components. There we go. Can you see it? Yeah.
Yeah, okay.
There are 2 repositories here. One is for the XLL per Python. Again, everything is still a work in progress. So
okay. So maybe there are some
rough around the edges still, but that contains the script and the example Excel spreadsheet that I used for this presentation. And then there is the importer repository that instead contains the software related to the importer and I think a basic configuration file. So these are the 2 main repositories that you can find information in. And the importer Python script already has a extensive read doc written by Katerina that is accessible from the GitHub itself.
Okay. And for those that are intimidated by GitHub, well, obviously we can contact you or Katrina perhaps. And I was wondering, do you plan to make an announcement or some sort of giving news on Imager-C maybe?
Yeah, the step that I'm going through right now is that I'm running a phase of test right now on some labs here at UMass.
Okay.
So to be sure that everything, like the nightly version mostly, because it's the one more difficult to test on a enclosed environment kind of thing,
Okay.
runs properly. And then I'm probably gonna post it on, there is already a topic on this on ImageSC that was the one I opened originally for asking question. And once I finish to iron out the last couple of bugs, like the usual kind of stuff, and finish to run the test, then I'm probably gonna announce that and hopefully release something along the line of a pre-packaged version of it that can be just drag and drop somewhere, and just a little help on how to set it up regarding the 2 configuration file, and then that should be enough for running a easy version, let's say, a simplified version of it, kind of thing. Yeah. Hope that answered. Yeah, I think Judith fell off.
Yes.
Yeah, looks like we might have lost her.
Yep.
Great, good. Well, I think we're pretty close to time anyway. Are there any final questions in the audience? Now, Alex, people can reach out to you with questions too after this, can't they? Do we have we can put your email address in the document if you're willing to drop that in the chat for us?
Yeah, I'm gonna do that right away. There we go.
Great, thank you. We'll add that to the document. So if anybody has any questions that come up whilst you're thinking about it, then please reach out to Alex. But that's lovely work again.
Thank you.
Yes,
Great stuff.
great work.
Yeah.
Thank you very much, everybody. Thank you very much, Alex. Looking forward to work with your tools. All right.
Thank you.
We'll be in
Good to
touch
see.
about the meetings in the fall. I think there's some discussion that it might be in September, not August at the normal 2-month cadence. So either way, we will reach out well in advance once we know the next date of the meeting, and we hope you can join us. Thank you again, Alex.
Super.
Thank you, Judith. Thank you, everyone.
Have a great
Thank you,
Great
everyone.
summer,
Have a good
everybody.
day.
Yep, bye-bye.
Bye.
Bye,
Bye-bye.
all.